Okay, so a very good evening. This is the 11th live discussion session of the course Geotechnical Engineering 1. The topic of today's discussion will be consolidation of soils. Previously, I have covered, I think, up till the stress distribution part, and also have given some questions from shear stress and earth pressure. I've already covered, I think, Bosing's theory, Newmark's chart, Westergaard's theory, and now coming to the consolidation. I think this chapter, consolidation and soil settlement, it has been divided into two parts according to the syllabus. This NPTEL syllabus, this has been divided into two parts. So in this problem solving session, I will be discussing uh, and giving some problems on the basics of the consolidation theory. Obviously, there are numericals also in this course, but the main numericals concerning the settlement part of soils will be there in the next live discussion session. So, in this problem solving session, that is the consolidation of soils of week 11, a basic introduction of consolidation, the parameters influencing the coefficient of consolidation, and some problems related to the degree of consolidation, time factor, and all these things will be there. Like the previous classes, this session will also have MCQ, some true false statements, and some numericals. So I hope you are sitting with your calculator along with your copies and pen, and I'll be first dictating the all the questions, one by one, as you know, and you have to write down the questions first along with the options, and the data of the numericals are very important. Please write them down very carefully. You can also take a screenshot if you are comfortable with it, and then I'll be giving you some time, approximately 15 minutes, and I'll start the discussion after that. And if you know the answer, please do not tell the answer or write the answer in the chat box during the time when I dictate the questions. When I start discussing the solutions after the break time, then you can one by one tell me the answer if you have solved the question. Otherwise, anyway, I'm going to discuss the answers in this session. Okay, so with this, I'll be now going to the PPT. Just a moment. Yes. So again, this is the 11th live discussion session of the course Geotechnical Engineering 1. The topic of today's discussion is consolidation of soils. I'll start dictating the questions now. Okay. So the first question is, yes, in partially saturated soils, the initial consolidation is due to. In partially saturated soils, the initial consolidation is due to. First option, squeezing out of water from the voids. Second option, expulsion and compression of air in the voids. Third option, expulsion of highly viscous water. And last option, none of these. I repeat the question. In partially saturated soils, the initial consolidation is due to first option, squeezing out of water from the voids. Second option, expulsion and compression of air in the voids. Third option, expulsion of highly viscous water. And last option is none of these. Do you have idea about the stages of consolidation? You know, right? The stages of consolidation.
Sir, first expulsion and compression of air in the voids.
That is the thing I've told you. I just asked you about your idea, and please don't tell
Okay.
the answers, okay? Don't tell the answers and don't write the answers. There are others also.
Okay, sir. Yeah, yeah, I have little idea.
Yes, yes. Okay, fine, fine. Just asking that whether you have idea or not. Anyway, so these are the four options. I'll now go to the second. Just a moment. Someone is. Okay, so I'll just wait. So yes, you have joined. Those of I think one person only. Abhinaya, you have joined now. This is the first question. Okay, of today's discussion. The topic is consolidation of soils. The topic is consolidation of soils. So please write down the first question. In partially saturated soils, the initial consolidation is due to, your options are squeezing out of water from the voids, expulsion and compression of air in the voids, expulsion of highly viscous water, or none of these. Okay. Okay. So next question. Consolidation of soils is due to load, which is, consolidation of soils is due to load, which is, your options are static and short term, dynamic and long term, static and long term, or dynamic and long term. I repeat the question. Consolidation of soils is due to load, which is, first option static and short term, second option dynamic and short term, third option static and long term, and last option is dynamic and long term. Okay, I hope the question was clear. I'll go to the next question. Yes. Secondary consolidation is mainly due to the secondary consolidation. Excuse me. Secondary consolidation is mainly due to the first option, expulsion of highly viscous water. Second option, plastic readjustment of solid particles. Third option, both of the above. Last option, none of these. I repeat the question. Secondary consolidation is mainly due to the first option, expulsion of highly viscous water. Second option, plastic readjustment of solid particles. Third option, both of the above. And last option, none of these. Okay. Next question. This is a true false statement, and I think it is pretty simple and easy. Time is an important factor in the consolidation of clays because of low value of permeability. Time is an important factor in the consolidation of clays because of low value of permeability. Is this statement true or false? I repeat the question, I repeat the statement rather. Time is an important factor in the consolidation of clays because of low value of permeability. Is this statement true or false? Please let me know if the audio is not working properly because there has been some problem with the OBS recorder. So if you can't hear, please stop me and tell me. Okay, if you have any difficulty in hearing my voice.
It is clear, sir, but some wind is coming, wind sound.
Yeah, wind is coming because the fan is on, and I
Okay,
cannot.
sir. Okay,
I
okay.
Yeah,
Suffocation will be.
yeah, I cannot put that off because of the heat. You know.
Yes, sir. Yes, sir. Understood.
Yeah, yeah.
Okay,
So
okay, sir.
please bear with that for another 1.5 hour. Anyway, so this was the statement, and you have to tell whether the statement is true or false. Okay. So I'll go to the next question now. Yes. Which of the following is not an assumption in Tarzagi's theory of one-dimensional consolidation? I believe there's a high. Yeah. Which of the following is not an assumption in Tarzagi's theory of one-dimensional consolidation? First option, soil mass is homogeneous and isotropic. Second option, soil is fully saturated. Third option, Darcy's law is valid. And last option, drainage of water occurs in both horizontal and vertical directions. Mind the question I've asked, not an assumption. I repeat the question. Which of the following is not an assumption in Tarzagi's theory of one-dimensional consolidation? Soil mass is homogeneous and isotropic. Soil is fully saturated. Darcy's law is valid. Or drainage of water occurs in both horizontal and vertical directions. Okay. Okay. Next question. Coefficient of consolidation depends upon. Coefficient of consolidation depends upon. First option, permeability. Second option, coefficient of volume change. Another term for this is coefficient of volume compressibility. Same thing. Third option, unit weight of water. Last option is all of these. I repeat the question. Coefficient of consolidation depends upon first option permeability, second option coefficient of volume change, third option unit weight of water, and last option is all of these. Okay. Next question. Yes, the first numerical. An undisturbed sample of clay 24 millimeter thick consolidated 50% in 20 minutes when tested in the laboratory with drainage allowed at top and bottom. The clay layer from which the sample was obtained is 4 meter thick in the field. How much time will it take to consolidate 50% with double drainage? If the clay stratum has only single drainage, calculate the time to consolidate 50%. Please let me know if you have problem in understanding the question.
Sorry, you want to time in same units, minutes?
Yes, what I want.
You want the time answer in the minutes or which units?
Let me check and tell you what I want. I want the answer, I believe, 24. I want the answer in days.
Oh, okay, sir.
Yeah. Okay. in any in any case, when you have these kind of questions,
Yes.
the time is involved, it is better to convert it into days, because in units, in minutes or seconds or hours, it will be a very long answer. Just cut it down to days. So you have understood the question, I believe. I'll just repeat it once. So you're asked to find out the time of consolidation, 50% consolidation, in the field sample of clay layer, field specimen of clay layer, which is 4 meter thick, once with double drainage and another time with single drainage. An undisturbed sample of clay 24 thick, consolidated 50 percentage in 20 minutes when tested in the laboratory with drainage allowed at top and bottom. The clay layer from which the sample was obtained is 4 meter thick in the field. How much time will it take to consolidate 50 percentage with double drainage? If the clay stratum has only single drainage, calculate the time to consolidate 50 percentage. Okay, so we'll get two answers. Time for consolidation, both the answer, just convert your answer to days. Okay, all right, next question. A soil sample which has been subjected to consolidation test has an area of 50 centimeter square. Dry weight of the sample is 190.24 gram. Initial height of sample is 25 millimeter. Taking G, that is the specific gravity, as 2.67, determine the height of the solids and the initial void ratio of the soil. I repeat the question. A soil sample which has been subjected to consolidation test has an area of 50 centimeter square. Dry weight of the sample. Dry weight of the sample is 190.24 gram. Initial height of the sample is 25 millimeter. Taking G equals to 2.67, specific gravity of the soil solids as 2.67, determine the height of the solids and the initial void ratio of the soil. Okay, I hope it was clear. Next question. An undisturbed sample of clay stratum 2 meter thick was tested in the laboratory, and the average value of the coefficient of consolidation was found to be 2 into 10 to the power minus 4 centimeter square per second. Now, assuming double drainage, how long will it take to attain half the ultimate settlement under the load of a structure? Even though I have mentioned the word settlement, the problems with respect to the actual settlement equations will be dealt with in the next session. So here you can do it in some other way, not considering the settlement in the equation. Okay, if you know the concept, you will know how to solve this. I repeat the question. An undisturbed sample of clay stratum 2 meter thick was tested in the laboratory, and the average value of the coefficient of consolidation was found to be 2 into 10 to the power minus 4 centimeter square per second. Assuming double drainage, how long will it take to attain half the ultimate settlement under the load of a structure? Okay, I believe the question is clear to you. Next question. Yes. Two clay specimens A and B of thickness 2 centimeter and 3 centimeter have equilibrium voids ratio 0.68 and 0.72 respectively under a pressure of 200 kilonewton per meter square. If the equilibrium void ratio, that is void ratio, equilibrium void ratio, you can consider that at that particular time when the sample is in equilibrium. Okay, equilibrium void ratio of the two soils 0.5 and 0.62 respectively on increment of pressure to 400 kilonewton per meter square. Find the ratio of the coefficients of permeability of the two specimens. The time required by specimen A to reach 40% degree of consolidation is 1 by 4 of that required by specimen B for reaching 40% degree of consolidation. Please let me know if you have any problem in understanding the question. Have you written down the question? Okay, I'll repeat the question once. Two clay specimens A and B of thickness 2 centimeter and 3 centimeter have equilibrium void ratio 0.68 and 0.72 respectively under a pressure of 200 kilonewton per meter square. If the equilibrium void ratio of the two solids 0.5 and 0.6 two solids are, I think I missed an R over here, are 0.5 and 0.62 respectively on increment of pressure to 400 kilonewton per meter square, find the ratio of the coefficients of permeability of the two specimens. The time required by specimen A to reach 40% degree of consolidation is 1/4 of that required by specimen B for reaching 40% degree of consolidation. Okay. Okay, so I'll go to the next question now. In consolidation testing, curve fitting method is used to determine. In consolidation testing, curve fitting method is used to determine. First option is compression index. Second option is swelling index. Third option, coefficient of consolidation. And last option is time factor. I repeat the question. In consolidation testing, curve fitting method is used to determine. First option, compression index. Second option, swelling index. Third option, coefficient of consolidation. Last option is time factor. Okay. Next question. This is not updating. Which of the following soils will generally have maximum compressibility? Which of the following soils will generally have maximum compressibility? Your options are sands, clays, gravels, or silts. I repeat the question. Which of the following soils will generally have maximum compressibility? First option is sands. Second option, clays. Third option, gravels. And last option is silts. Okay. Okay. Next question. if the coefficient of permeability is doubled and the coefficient of volume compressibility is halved, the coefficient of consolidation, first option, increases by 2 times, second option, decreases by 2 times, third option, increases by 4 times, last option, decreases by 4 times. Just a moment. Yes, I repeat the question. If the coefficient of permeability is doubled and the coefficient of volume compressibility is halved, the coefficient of consolidation, first option is increases by 2 times, second option is decreases by 2 times, third option increases by 4 times, and last option is decreases by 4 times. Okay, next question. During consolidation, as water escapes out, during consolidation as water escapes out, first option is both neutral and effective pressures reduce. Second option, both neutral and effective pressures increase. Third option, neutral pressure reduces and effective pressure increases. Last option, neutral pressure increases and effective pressure reduces. I repeat the question. During consolidation, as water escapes out, first option, both neutral and effective pressures reduce. Second option, both neutral and effective pressures increase. Third option, neutral pressure reduces and effective pressure increases. Last option, neutral pressure increases and effective pressure reduces. Okay. Next question. Curves indicating the distribution of excess hydrostatic pressure are called. Curves indicating the distribution of excess hydrostatic pressure are called. First option, isobars. Second option, isochrones. Third option, isoheights. Last option, none of these. I repeat the question. Curves indicating the distribution of excess hydrostatic pressure are called. First option is isobars, second option isochrones, third option isoheights, last option is none of these. Okay. Next question. Yes. Time factor is, first option, a non-dimensional parameter. Second option, a function of the degree of consolidation. Third option, directly proportional to the permeability of soil. Last option, all of the above. I repeat the question. Time factor is, first option, a non-dimensional parameter. Second option, a function of the degree of consolidation. Third option, directly proportional to the permeability of soil. Last option, all of the above. Okay. Next question. Consolidation time of a soil sample. First option, increases with an increase in permeability. Second option, increases with a decrease in compressibility. Third option, increases with a decrease in unit weight of water. And last option, increases with a decrease in permeability. I repeat the question. Consolidation time of a soil sample. First option, increases with an increase in permeability. Second option, increases with a decrease in compressibility. Third option, increases with a decrease in unit weight of water. And last option, increases with a decrease in permeability. Okay. Next question. Another numerical. Two identical clay samples. Just a moment. Yes. Two identical clay samples of same sizes designated as A and B are subjected to consolidation tests under identical conditions. Drainage takes place through one phase in sample A and through both phases in sample B. 50% consolidation of sample A occurs in 10 minutes. Calculate the time required for 50% consolidation in sample B. So there are two samples of same sizes, same material clay A and B. Consolidation test has been performed under identical conditions. Now A has drainage through one phase, that is single drainage, and B has double drainage. So if in sample A 50% consolidation occurs in 10 minutes, how long will sample B take for same degree of consolidation? I repeat the question. Two identical clay samples of same sizes designated as A and B are subjected to consolidation tests under identical conditions. Drainage takes place through one phase in sample A and through both phases in sample B. 50% consolidation of sample A occurs in 10 minutes. Calculate the time required for 50% consolidation sorry, in sample B. Okay, I hope the question was clear. Next question, in the last question. Yes. A fully saturated clay specimen is subjected to a pressure of 200 kilonewton per meter square in the consolidation test. Determine the degree of consolidation after a period of time when the average pore pressure is 60 kilonewton per meter square. So there is a fully saturated clay specimen on which the pressure exerted is 200 kilonewton per meter square in the test. Now when the average pore pressure is 60 kilonewton per meter square, you have to find out the degree of consolidation. I repeat the question. A fully saturated clay specimen is subjected to a pressure of 200 kilonewton per meter square in the consolidation test. Determine the degree of consolidation after a period of time when the average pore pressure is 60 kilonewton per meter square. Okay, I hope you have written all the questions. Okay, it is 6:51 right now. Approximately 15 minutes I'll give. I'll start at 7:05. Okay, 7:05 to 7:06 I'll start discussing the solutions. Okay, you have approximately 15 minutes. Please solve it. Hello, am I audible? Hello.
Yes, sir.
Okay, so have you solved the questions?
Sir, I have done up to 1 to 7 question because power lost after that.
Oh, okay, okay.
I could not copy also after the seventh example.
Oh, yeah, yeah, I saw that only one person was there in the meeting. Anyway, no problem, no issues. Just take a screenshot after, I give you the solutions.
Okay.
Excuse me. Okay, so I'm going to start, and the other person who was there in the meeting, Dheeraj Raghuvanshi, have you completed the, questions?
Sir, yes, initial maybe 5 or 6 only.
Why, you needed more time or what?
No, sir, you start the session. Actually, it's also a learning process, so
Okay, okay,
no
fine,
issues, sir.
fine. Yeah, yeah. Actually, no issues. So as we proceed, you can, carry on your work. Okay.
Yes, yes.
Okay. So I start with the discussion part. You can mute yourself, Dheeraj. I think yes,
Sir.
yes, Dheeraj, mute yourself. Okay. So I'll start with the discussion part. You know. So the first question was, in partially saturated soil, the initial consolidation is due to. What is the answer? I believe you have already mentioned the answer previously. What is the answer?
Option B, sir.
Yes, expulsion and compression of air in the voids. Partially saturated soil means it has both water and air in the voids. So there are three stages mainly. First one is the initial consolidation, which is similar to compaction. That is the expulsion of air in the voids. Then comes what? Primary consolidation. And then comes secondary consolidation. So in the initial phase of consolidation, in the initial consolidation stage, in general, in nature, we have soils which are mostly partially saturated. On the application of load, first the air gets expelled out. So the answer is expulsion and compression of air in the voids. This is the process that goes on during the initial consolidation stage. Okay, expulsion and compression of air in the voids.
Sir,
Yes.
is it complete expulsion of the air, sir?
See, first of all, air will get expelled out. Okay. Then expulsion of water will happen. Now, I am not saying that the expulsion of water will start only after all the air is driven out. Okay. That is a very, pure concept, theoretically pure concept. Okay. But on the application of load, since air, is easier to expel out than water, first of all, air gets expelled out. Then water starts. So when water is getting expelled out, it might happen that in the lower regions, in the lower depths of soil, there are some air voids. From there, air is also escaping out as water. That might happen. But initial phases, the air is the first thing that gets expelled out. If the soil is partially saturated. Now, if it is completely saturated, will it have any air voids? No, right?
Even dry soil also it is same answer, na, sir?
If it is dry soil, then no need of consolidation, right? Consolidation will not occur. It is only compaction. Consolidation is the removal of
Immediate
water.
settlement, immediate
Yes.
compression.
If you are taking a dry soil sample, that means the voids are only filled with air. So even if you go for the consolidation like process, Okay, if it is dry soil, initial consolidation is the only and the primary stage that will be followed. The primary and secondary consolidation stages will not be there theoretically for dry soils. Okay, so in partially saturated soil, the initial consolidation is due to expulsion and compression of air in the voids. Okay, next question. Consolidation of soils is due to load, which is, what is the answer?
Sir, answer C, static and long term.
Yes, very good. Static and long term. For consolidation, static and long term loads is essential. It is a time dependent process. Good. Next question.
Sir,
Yes.
one thing I want to discuss in this question, that if we see that dynamic and long term load or dynamic and short term,
Hmm.
so something like a railway track on which railway is moving continuously, so it can be considered dynamic and long term or dynamic and short term load, and or it will be responsible for this consolidation also.
Dynamic and short term is required for compaction. Okay. Dynamic and short term. For example, when you are performing the laboratory test, Proctor compaction test, okay, you are doing it manually. So on every blow of the rammer on the soil, you know the force of your hand will not be the same, right? So it is dynamic and short term load. What you are saying is railway tracks. Okay, railway tracks are not dynamic and long term. It is dynamic and short term because after a train is passing by, after a train is passing by, then what happens? It takes time before which another train is going to pass by, right? It is not like trains are passing by all the time. Suppose there is a railway track in any station of India. Suppose there is a railway track. Okay. Now there is one train which passes the railway track at suppose 7 in the morning. Okay. It is crossing that track. It has a particular weight because it carries some specific number of passengers. Right. Now the next train that will pass after that, it might pass the track at around 8 o'clock, isn't it? At around 8 o'clock, and that train will have a different number of passengers. It will have a different load, isn't it? So it is dynamic load and short term load, not long term. Long term means which is there consistently there. For example, a building on a soil. Once the building is built, it is there consistently. It is a long term load. Okay, long term load. Now the building is subjected to seismic vibrations and that is continuing for a very long time. Then it can be said as dynamic and long term. Is it clear?
Yes, sir.
Yeah. So this question, consolidation of soils, is due to load which is static and long term. This is the correct answer as mentioned by you. Okay. Next question. Just a moment. Let me check. Yes, it is good. Secondary consolidation is mainly due to the, what is the answer?
Answer C again.
Yes, very good. Expulsion of highly viscous water in the soil particles which are attached to the soil particles, and then when that is expulsed, there is a permanent readjustment of soil particles. There is plastic readjustment of soil particles. Okay, that happens in secondary consolidation. So this part is generally not taken during the calculation and laboratory testing process. It might be taken in some cases, but generally during the calculation process, this part is generally not taken because this highly viscous water in the soil particles, contribution of their this highly viscous water to the pore pressure is still questionable, because I don't think, and I have seen in books and papers, this highly viscous water, it is not considered when we are doing solving some numericals or delving into the problems with pore pressure. So yes, as you have mentioned correctly, secondary consolidation is mainly due to the expulsion of highly viscous water which leads to the plastic readjustment of solid particles. So both of the above, correct answer. It happens simultaneously, one after the other. Okay, good. Next question. Yes, tell me. This is also very simple. Time is an important factor in the consolidation of clays because of low value of permeability. What is the answer?
Yes, sir, true.
Yes, obviously, because clay has high porosity and low permeability. So, for consolidation in clays, to expel out the water, it will take much more time than that in granular soils. Okay, this statement is true. Sorry. Next question. Which of the following is not an assumption in Terzaghis theory of one-dimensional consolidation? What is the answer?
Sir, option D.
Drainage occurs in both horizontal and vertical directions. So, what should be the assumption?
Drainage occurs only in vertical direction.
Not vertical to be specific, it occurs in the direction of the applied load, isn't it? It occurs in the direction of the applied load. Now, generally, we are applying the load vertically. That's why you are saying vertical, right? Isn't it? You're saying vertically because we apply load in the vertical direction.
Uh, yes.
Yes. So if there is a soil sample and we try to consolidate the soil sample by applying load in the horizontal direction, then according to Terzaghis theory, the drainage of water will occur in the horizontal direction. It will occur in the direction of the applied load. Now, in general sense, for any kind of geomaterial, the major principal stress is vertical and the minor one is horizontal. Okay, so in any kind of testing, the major principal stress, the applied pressure is always vertical. That's why, in general sense, the drainage of water will occur in the direction of the applied load, which is specifically vertical in the case of soil or rocks. Okay. So yes, drainage of water occurs in both horizontal and vertical direction. This is not an assumption in Terzaghis theory of one-dimensional consolidation. Right answer. Okay, next question. Coefficient of consolidation depends upon. Tell me.
All of these.
Why?
In the formula, these all three things are present.
What is the formula? Tell me.
Uh, this is K oblique MV into gamma W.
Yeah, oblique is divided by, right? Say divided
Yeah,
by.
yeah, divided by, yeah.
K divided by MV gamma W. Very
Yes.
good. So what is K? What is K?
K is permeability.
Permeability
Uh,
coefficient. Very good. MV.
yes. MV is coefficient of volume change, and gamma W is unit weight.
Very good. So coefficient of consolidation depends upon the coefficient of permeability, coefficient of volume change, and the unit weight of water. Okay. So all of these is the correct answer. Okay. Next question. Have you solved this sum?
Mm, yes, sir. I solved, but answer is my answer is coming 382. I don't know how much it is correct.
In my
382 days.
case, it came 386 days. Anyway, let's see. Okay, if the method is right, answer. And what is the second answer of the second part?
No,
Which
second part not yet solved.
okay,
1000.
yes, 1000.
543.2
Yes,
days.
yes. So you will take it as rounding up. Okay, rounding up 1544. Whatever the value you get in days for in decimal for days, okay, you will take it as rounding up. Okay, so let's see. So I have mentioned degree of consolidation. So the same degree of consolidation, the time factor will be same. Okay, because degree of consolidation and time factor, they are correlated. So now we know that time of consolidation is equals to time factor multiplied by d square, drainage depth, drainage length, whatever, divided by cv, coefficient of consolidation. Okay, now when tv is same, okay, and this and the soil is also same, right? I have collected the soil from the field, so cv will be same for the soil. So now I can say for same tv and cv, time is directly proportional to the square of the drainage length. Okay, so here I have to find out the time of 50% consolidation in the field. So time for consolidation in the field divided by time for consolidation in the lab is equals to df in field, drainage length in field, drainage length in lab whole square, is it? Now sorting it out, in field will be equals to time of consolidation in the lab into drainage length in field divided by drainage length in lab whole square. So df in field equal to, now the time taken in lab, how much it is, it has taken 20 minutes. So it is, first keep it in minutes, 20 minutes. What is the drainage length in the lab? 4 meter, divided by 2 it will be, because double drainage, isn't it? So 2 meter, that is 200 millimeter, so, sorry, 200 centimeter, right? I can write like this, 200 centimeter, and for the laboratory it was 24 millimeter, means 12 millimeter, because d equals to h by 2. D equals to h by 2 for double drainage. For single drainage, this is for double drainage. For single drainage, D equals to H. So 200 by 1.2 it will be in centimeter. Now converting everything, approximately my answer I have got as 386 days. In the second part, the clay stratum in the field has only single drainage. So in the second, this is the first part. In the second part, this value in the field will be nothing but, it will be equal to 20 minutes. For single drainage, it will be D equals to A, that is 400 centimeter. Okay. Sorry, here there is a square. Okay, I missed the square over here. The square. And here also 400 divided by, in the lab it was double drainage, so 1.2 will be equal to 1.2 whole square. So simple thing, 400 is twice of 200, twice whole square is 4 times, so 386 4 times will give us approximately, rounding up this value to 1544 days. Okay. I hope it was clear.
Yes, sir.
Yeah. If you haven't solved, you can just take a screenshot. I'll be sharing the PPT anyway. Okay, next question. Let me save this. Next question. Yes. Have you solved this question? Have you solved this question?
Have not done, sir. If you give me 1 minute, I can do it.
Let's do it together then. Okay. Let's
Okay,
do it
sir.
together. So the
Okay, sir.
height of the soil solids,
Mm.
okay, will be equal to how much? The mass of the dry soil divided by the specific gravity multiplied by gamma w. I don't take gamma w, I'll take rho w because it is density, right? Not the unit weight. I'll take rho w into the area. How it is coming? G equal to rho s by rho w. What is rho s? Density of soil solids. Now mass by volume is density. So mass of dry soil divided by HS into A, height into area gives us the volume. So rearranging that equation of G, we get this equation. Now the mass of the dry soil, we know it is 190.24 divided by G is 2.67 into rho W is 1 into area is 50. 14.25 mm, right? 14.25 mm. Are you getting the same answer? Same answer, 14.25 mm. Okay. Now finding out the void ratio using the height of soil solids method. E0 equals to, what is the formula using the height of soil solids?
H minus HS by HS.
Yeah. So I'll take H initial as H0 if I take, okay, minus HS divided by HS. So HS is this. What is the value of H0? H0
25
is
millimeters.
H0 is, yes, 25. To solve it, I believe you're getting 0.75, isn't it? Are you getting 0.75? Let me know if
Sir,
you're
very
getting.
close to that.
Yes,
Very close to that.
yeah,
0.74.
yes, approximately 0.74 to 0.75. So this is the way you solve this using the height of the soil solids method to find out the initial void ratio of the soil sample. Okay. Okay, so this has recorded, fortunately. Next, just save once. Undisturbed sample of clay stratum 2 meter thick, tested in laboratory. Value of coefficient of consolidation was found to be 2 10 to the power minus 4 centimeter per second, assuming double drainage. Okay. How long will it take to attain half settlement? Have you solved this question? No. Right.
I have not done, sir.
Okay. So see, half settlement means 50% degree of consolidation. Okay. Half settlement means 50% degree of consolidation. Now when U is less than 60%, what is the formula we use to find out the time factor? Time factor TB equals to pi by 4 into U by 100, right? U by 100 whole square. Okay. So find out the time factor for 50% consolidation. 50 by 100 whole square, approximately 0.197 as per my,
196. Yes, sir.
yeah,
197.
197. Okay. So now time taken for this. Okay. Double drainage. So D will be equals to H by 2. If I take 2 meter, that is 200 centimeter, D will be equals to 100 centimeter. Isn't it? 100 centimeter. So now time taken for 50% consolidation or half settlement is equals to TB T into D square divided by CB. Put the values, and approximately you're getting 113 point something, or 100, approximately 114 days, converting everything. This is CV, okay, 2 to 10 to the power minus 4. Have you got it?
Yes, sir. Same answer.
Yeah, okay. Okay, next question. I believe you haven't solved this, so I'll just start right away. So in this question, I have asked you to find out the, I think, the ratio of the coefficients of permeability. Let us first find out the coefficient of volume compressibility. What is the formula for the coefficient of volume compressibility? MV equals to minus del E divided by 1 plus E0 into 1 by del sigma. Okay, 1 by del sigma. Now, for sample A, okay, for sample A, just see very carefully, the initial void ratio at 200 pressure was 0.68. After increment by 200, it was 0.5. Okay, so for A, for sample A, del E will be final minus initial, right? That will be minus 0.18. And what is del sigma? It is 200. Okay, not writing units over here. Similarly, for B, it was having void ratio of 0.72. After increment of pressure by 200, it became 0.62. So for this sample B, del E will be equals to how much? Minus 0.1. Final minus initial, right? Void ratio is obviously not negative, but I am considering the change in void ratio. So the final is lesser than the initial, that's why. And obviously here also the increment in stress is 200. Obviously, because it was initially 200, then become 400. Now if we put the values, for A, E0 will be 0.68. For B, E0 will be 0.72. Now put the values and find out the value of uh, MV A and MV B. My answer I have reduced it to meter cube per meganewton. So this is 0.5 too large. 0.536 meter square per meganewton. You can also keep it in kilonewton, no worries. And this is 0.291 meter square per meganewton. Okay, you can check it. This is the value of MV and MA and MV. Okay, now just quickly I will find out the ratio of MVA to MVB. I will be getting approximately equal to 1.845. Okay, that's why I said it doesn't matter if it is in meganewton or kilonewton, because ultimately the ratio is the thing which I have asked for. in the ultimate case, obviously, you have to find out the ratio here also. Now, for the same degree of consolidation, I have mentioned 40% degree of consolidation in both the cases. For the same degree of consolidation, okay, now these two specimens, unlike the previous sum, they are not same. Okay, so in this equation, that is T time for consolidation equals to TB d square by CB, isn't it? TB d square by CB. Okay, this is same for both because same degree of consolidation. So now this T will vary according to d square by CB, isn't it? D square by CB. So now CB A, what is the formula for CB? CB equals to K by MV gamma W, right? Isn't it? CB equals to K by MV gamma W. So
Yes, sir.
what is K? K will be equals to just the the concept how I am proceeding. K will be equals to how much? CB MV gamma W. So the ratio of Ka to Kb will be equal to the ratio, the product of the ratios of CBA to CBB and MVA to MVB, right? Now MVA to MVB we have found out. We need CBA to CBB. Now CB, from this part, from this relationship, I'll just directly write CBA to CBB. It will be dA by dB whole square into time is inverse proportional, so into TB by TA into TB by TA. Now calculate the value of CBA by CBB. So time taken, see, time taken for sample A is 1/4. Sample A is 1/4. So TB by TA is 4, isn't it? TB by TA is 4. Now the sample has thickness of 2 cm and 3 cm. Okay, sample has thickness of 2 cm and 3 cm. And have I mentioned double drainage over here? Have I mentioned double drainage? Okay, nothing is mentioned. You can take double drainage or single drainage. Anyway, the ratio will be counted. So dA by dB 2 by 3 whole square. dA by dB 2 by 3 whole square. So ultimately 4 by 9 into 4, that is 16 by 9, isn't it? Can you follow? Or I should repeat?
Yes, sir. Yes, sir. Yes, sir.
You can follow, right? So
Yes, sir.
this ratio of CBA to CBB will be 16 by 9. Now I have to find out ultimately the value of Ka to Kb. So very easy. It will be CBA by CBB multiplied by MVA by MVB. Now what is the answer? Tell me. I'll add the answer over here. Approximately 3.28 you are getting, right? Are you getting 3.28 approximately? Hello? Are you getting 3.28 as the...
Sir, I didn't do it, sir, because of that power problem.
Oh, okay, fine.
I'm following just this.
Yes, so you can understand the concept, right? Why
Yes, sir. Yes,
I am
sir. It's
approaching
clear.
this in this way. Okay, fine.
Yes, sir.
So what I have done over here to find out the ratio of Ka to Kb, I have first found out the ratio of MVA to MVB using the given data, then CBA to CBB. First the ratio of the coefficient of volume compressibility of the two soils, then the ratio of the coefficient of consolidation of the two soils. Multiplying those two ratios, we get the ratio of the coefficient of permeability of the two specimens. Okay, things to keep in mind: these are two different soils, so CV will be different in these two cases, but same degree of consolidation, so the time factor will be same. Okay, save this. I hope this had been recorded. Yes. Okay.
Drainage also get cancelled, na, sir?
Yes. What?
DA by DB ratio also one, na? Whatever may be, single or double.
Yes, whatever it is, single or double, if it is single, then H1 by H2. If it is double, then H1 by 2 divided by H2 by 2. So 2
Yeah.
gets cancelled. So it doesn't
Yeah.
matter in this question whether it is single drainage or double drainage. The thickness only matters.
Okay, sir.
Okay. Yeah. So after this, next question is, okay, tell me the curve fitting method. What do we need to find using the curve fitting method? The coefficient of consolidation, right? Using the curve fitting method, we find out the
Yes,
coefficient
sir.
of consolidation. Okay. Okay. Next question. Soils having maximum compressibility. Very easy question. Tell me.
Clays.
Yes. Very good. Clay having the maximum compressibility among all the given soils. Okay. Next question is, yes, tell me. Permeability is doubled and volume compressibility is half. Coefficient of consolidation. So CB equals to K divided by MV gamma W, right? So I am saying permeability is doubled, so K multiplied by 2 and volume compressibility is half, MV by 2. So this is CB. CB dash will be 4 times CB. Okay, don't light it like this. So it is getting 4 times increment, right? Understand by this equation? Yes?
Yes, sir. Yes,
Increase
sir.
by
Yes, sir.
increase by
Yes,
4 times. So it
yes,
is
sir.
increasing by 4 times. Yes. I think your voice is breaking a bit, but yeah, okay. I could hear you now. So if the coefficient of permeability is doubled and volume compressibility is half, the coefficient of consolidation increases by 4 times. Okay. Next question. During consolidation, as water escapes out, very easy question. What happens? Tell me. Neutral pressure is the pore pressure, right? It reduces as the water escapes out, and the effective pressure increases, isn't it?
Yes, sir.
Yeah. So
Is
third
it a
of
neutral pressure or hydrodynamic pressure, sir?
hydrodynamic pressure or neutral pressure, that hydrodynamic pressure, if you want to like consider, okay, you have to take the change in the neutral pressure into consideration, right? So if we say like total stress equals to effective stress plus pore pressure, and then I want to say effective stress equals to total stress minus pore pressure. This pore pressure is not the hydrodynamic pressure, right? It is the static pore pressure into consideration. So using the hydrodynamic pressure or the hydrodynamic lag in the consolidation process, I cannot explain the effective and total stress in that manner. Can I?
Actually, in consolidation chapter, we use U bar, sir, not U.
Yes, I know. We use U bar. You can also write over here the hydrodynamic pressure.
Okay,
Okay,
sir.
you can
Okay, sir.
also write
Okay,
here
sir.
hydrodynamic pressure, but in general sense, like when we
Yeah, in
consider the
that case,
total
C
and
is
effective,
correct.
yeah, in general sense, when we consider total and effective stress in a soil in soil, then for this effective stress, we know it is total stress minus pore pressure. Now, under the pore pressure in consolidation part specifically, we talk about the hydrodynamic pressure. One is the general sense, one is the specific case. So I have mentioned over in the general case. If I would have mentioned over here hydrodynamic pressure, then you would have preferred that answer over the neutral pressure, isn't it?
Yes, sir. Okay, sir.
Yeah, that is the scenario I'm talking about. Okay, so it is clear, I believe, to you. The third option is the answer over here. Next question: curves indicating the distribution of excess hydrostatic pressure is called. I think you know this. You've already mentioned in one class. What is the answer?
Isochrones.
Yes, isochrones. Distribution of excess hydrostatic pressure. Okay. Next question. Time factor is. What is the answer? Any guess will be, you know.
All of the above, sir.
Yes, very good. Non-dimensional parameter, obviously, time fraction is a function of degree of consolidation, as we all know, and it is directly proportional. Time factor, this is TB, sorry, TB equal to CBT by D square, and CB equals to K divided by MV gamma W into T divided by D square mathematically, right? So K numerator, so it is directly proportional to the permeability of soil. So all of the above. Very good. All of the above is the correct answer. I think the similar question is here. Consolidation time of a soil sample. What happens? You can tell me. I'm just writing it here anyway. TV d square by CB equals to TB d square divided by what is CB? K by MV gamma W. Okay. So let's just see the all the scenarios. Increase with an increase in permeability. No, because it is in the denominator. So it will not. Decrease with a decrease in compressibility. Compressibility, if it decreases, sorry, increase. If it decreases, this goes to the numerator. So the actual equation becomes time equals to mv gamma w, okay, into tv d square, isn't it? Divide by k, divide by k. So with a decrease in compressibility, time will decrease, not increase. This is wrong. With a decrease in the unit weight of water, time will also decrease. This is also wrong. Now the last option, decrease in permeability will cause an increase in time. Only this is correct. Could you follow?
Yes, sir. Clear.
Yeah. So conservation time of a soil sample increases with a decrease in permeability. Okay. Next question. Identical samples of clay designated A and B. Here also clay samples, same sample clay. Okay. 50% consolidation of A and the same for B. So U is constant, TB is constant. In the first case, so the sample thickness is not given. So for A, drainage takes place to one phase in sample A. So it will be H, single drainage. For B, it will be how much? Same size, H by 2, right? H by 2. Now all the other factors remaining constant, TA by TB will be equals to how much? dA by dB whole square, and that gives us how much? 4, isn't it? So just rearranging, time taken for B for 50% consolidation will be equals to TA divided by 4. TA is 10 divided by 4, that is equals to 2.5 minutes. 2.5 minutes. Is it clear? Hello?
Yes, sir. Yes, sir.
Yeah. Okay. Last question was this one. So, any idea how to solve this?
Yes, sir. We have a degree of consolidation formula.
What is the formula? Tell me.
Effective stress by total stress into 100.
Effective stress by total stress or effective stress
No,
at
no, correct, sir. Correct, sir. What I told is correct only. You
no,
check
no,
it.
it is the degree of consolidation. We know that. But see, you are saying what? Again, you say degree of consolidation
Is
is
nothing but effective stress divided by total stress into 100.
okay. So effective stress divided by total stress, right? So then, at which stage you are considering this? Tell me. At one particular stage, how can you find out the degree of consolidation with respect to the 100% degree of consolidation?
Anywhere you can calculate, no, sir. Total stress remains constant.
Total stress remains constant, but see this thing. See, I'm not talking about see, the final. At some point, you have to calculate the value to compare it with the final value. Then only you get the degree, right? Like how much percentage to 100 percentage. Like at one particular stage of consolidation, I have total stress, effective stress, and pore pressure.
Yes, sir.
Now, if I divide this and this is one particular stage. How can I find out this degree of consolidation?
For example, in this example,
Hmm.
total stress is a 200 kPa,
Yes,
and then pore water pressure at particular stage is 60.
yes,
Therefore, effective stress is 200 minus 60. It is 140.
yes.
Therefore, it's 140 by 200 into 100.
Now see, okay, now see.
Hmm.
You
Okay,
have
sir.
done correct, but just I'll just tell you my explanation. Okay, okay, this is not getting deleted. I'll use it later on. Okay.
Okay, sir.
So initially, so the sample is subjected to a pressure of 200 for the entire time during the consolidation process. Now the consolidation process starts from 0% to 100%. It ends, right? During that
Yes, sir.
stage, at any particular stage, I'm saying the pore pressure is 60. At any particular stage, the pore pressure is 60. So at that particular stage, suppose at that particular stage, stage T or stage 0, at that particular stage, the total pressure, how much it is? 200, right?
Yes, sir.
What is the pore pressure? 60.
Pore pressure also 200, sir, at zero time.
No, 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 no.
You are asking what is the zero means here?
No,
Time zero,
no.
na?
Zero means this stage. Zero means this stage.
Okay. That means time is not zero.
Time is not zero, but I am
Okay, okay,
considering
okay.
0 and F. Okay,
Understood, sir.
let
Understood.
me do it in this way. Zero is confusing, I know. Average pore pressure. This time I'll take it as T, and the
Okay.
final as F. So at time T, when
Hmm.
the pore pressure is 60, at that time sigma equals to 200, U equals to 60. So what is the value of effective stress? 140.
140.
Yes. Now at the final stage of consolidation,
Okay, sir.
sigma will be 200. At that time, water has been drained out. U will be how much?
Zero.
0. What is sigma?
Effective also 200.
200. Now, this is at time t, this is at time f. Now, oh, now to find the degree of consolidation at this stage, you divide the effective pressure at t to the effective pressure at final and then multiply by 100.
Yes, sir.
That
Same thing I told you, na, sir.
Yes, same thing you told me, but at one particular stage, if we divide, we cannot get the degree of consolidation. Degree of consolidation means at that particular stage to the final. See, when you are calculating settlement percentage, degree of consolidation means what? Initial settlement at that particular time to final settlement, right?
Yes, sir.
Yes, so the final value of settlement or stress should be taken into consideration. Okay, and the effective stress is something that causes the settlement. So in this case, this effective stress at the time t with respect to the effective stress in the final stage. That will only give us the value of u. Your answer might be correct, but you're not dividing this to this, dividing this by this. Since the pore pressure at final will be 0, that means the effective stress is equal to the total stress at the final stage. So since you are saying that at this time t and at this time f, so these two stages should be taken into consideration to find out the degree of consolidation, because we are calculating it in percentage. So means out of 100 how much. Whenever we are saying out of 100 how much, that means the ultimate thing we are taking into consideration, right? Because this one, this stage f, this is 100% consolidation, right?
Yes, sir.
Isn't it? So this is 70% consolidation. So whenever we are saying out of 100 how much, we should be taking the final stage into consideration, right? We cannot take only from one particular stage. So that is the reason the division, the ratio of the effective stresses should be taken into consideration at the stage t to the stage final. Okay.
Yes, sir.
Do you have any doubt?
May I know, sir, what is the wrong in which the formula which I used?
The formula is right, but you are saying that you are taking this divide by this, right?
I told effective stress by total stress into 100.
Total stress into 100, but total stress is not something we are taking here. See, how can you find out the ratio from effective? When we are calculating the degree of consolidation, we are taking settlement to settlement. The settlement is the same parameter, but effective stress and total stress, they are not same parameters, right? They are different parameters. Even though
Yes,
they are
sir.
the stress parameter, they are different parameters. So
Hmm.
the first thing which is wrong over here, you are dividing two different parameters to find out one particular degree. That is something wrong. And secondly, you are taking only one stage. You are taking only one stage. Okay. For example, I am calculating the marks. Okay, out of 100. I have to calculate out of 100, right? The percentage out of 100. So I cannot just take over here one stage and say, okay, this is no, because I need to know final how much can it go. We know that in an examination, a person can score out of 100 he can score. Then only I am
Yes, sir.
keeping the marks out of 100, right?
Hmm.
So over here also I have to know the final value, and over here the final value we know of the effective stress, because this is the one causing the settlement, isn't it? And we know that degree of consolidation is settlement at a particular time to settlement at the right at the 100% consolidation. So we take over here settlement at this effective pressure at this stage divided by effective pressure at the final stage. Your calculation was correct, just a bit twist. You're not dividing this to this, you're dividing this by this.
Yes,
Okay.
sir. I understood. What is
Yes.
the problem here is effective stress at the final is also equivalent to total stress always, sir.
Yes, total stress always, I know that, but I'm just like, see,
Okay,
this
okay,
is
okay.
this is equal to total stress, it will be always right.
Yes, sir.
But the concept is not dividing this to this is the way
Okay.
you're getting this. I
Hmm.
understand. So if you wanted to say initially that the effective stress in the final will always be equal to the total stress, that's why I'm saying,
Okay,
then I
sir.
would have accepted, but I thought that you are dividing this by this. Could you get it?
Yes, sir. Yes, sir.
Yes. So how are you getting? See, this this formula, this sigma t divided by sigma. Okay, sigma t by sigma. When we know that sigma t does not have a pore pressure, but sigma has a pore pressure.
It is
So
inverse, sir. It is inverse, not sigma t by sigma.
then what is sigma t by
It's
sigma, right? Sigma t is this one 140 divided by sigma 200, isn't it? U equal to sigma t by sigma,
okay.
what you mentioned, right? Sigma t by sigma. So sigma t by
I
sigma,
I
yes,
mentioned sigma effective by sigma total, sir. That's what I told you.
yes, sigma effective is sigma t bar. I have mentioned over here. This sigma effective.
Hmm.
At the stage T, I am mentioning U as per your definition, sigma T bar, sigma T effective divided by sigma. Now, why this formula is a misnomer? Because this particular thing has a pore pressure. This doesn't have. This has no pore pressure. Like what to say, pore pressure. Uh, Anything like pore pressure coefficient or anything. It does not have the pore pressure. This has the pore pressure. Then if we divide this definition is becoming a misnomer, right? This definition is becoming misnomer, even though this means this, we know that. So while defining, this is the definition. And if you want to say, like, if I would have given you an MCQ, suppose, like the final effective stress after 100% consolidation is equal to the option. In there, one of the option is initial effective stress. This is the correct answer, because by calculating u equal to 0, so sigma f bar equal to sigma, that we know. That is okay. But the actual definition, how should we calculate the degree of consolidation, that I am explaining over here.
Okay, sir.
Okay, na?
Okay, sir.
So I think it is clear to you. Your answer, your technique was not wrong, but the way I am getting it to it, that I am showing it over here. Okay.
Okay, sir. Fine, sir.
Yeah. So thank you for attending the session. This has been quite an interactive session from all of you. And
Thank you, sir.
I believe two of you are there. Okay, yes, two of you are there, and I will just end this session now. Thank you for attending the session. We'll again meet on the coming Friday with the 12th discussion session. Okay.
Thank you, sir.
Yeah.